So now I think I will give the floor to Dr. Roland. So he will give the starting, means he has today series of talk, and he will start with the introduction to PFOS and PFAO and basic information on developing related inventories. Okay, Roland, he already started sharing his screen. Okay, Roland, please go ahead. Your slides are visible. Roland, I think your mic is in mute.
So,
yeah, perfect.
Okay. Yes. Yes, the first presentation will be an introduction to PFOS and PFOA and developing the related inventory. So these are the first fluorinated POPs which we have in the convention. At the moment, it needs to move. So what is PFOS and its salts, and PFOS-F? I mean, that's how it is listed in the Stockholm Convention. So PFOS is perfluorooctane sulfonic acid, and it is a fully fluorinated substance, here alkyl with 8 carbons, which is commonly used as a salt or incorporated into larger molecules or polymers. So these other molecules and polymers, these are the related substances. And PFOS-F is intermediate for the synthesis of all PFOS-related substances. So PFOS-F has been listed to restrict all PFOS-related substances, not only PFOS. What the specific is of these perfluorinated substances is that they are highly persistent. So they are more persistent than the chlorinated POPs. Actually, for groundwater and for soil, for PFOS, we do not know any degradation. This means we are not talking about 10 years pollution or 100 years pollution. It can go longer. Yeah, so we do not know a time frame when they will degrade in soil or groundwater. They are fulfilling the toxicity criteria, and you might ask, oh, but why are they used then? So they are used because they are the best surface active compounds with extremely low surface tension, and they are the only compounds which are nicely fat repelling and water repelling. So this can give materials like textiles and carpets water repellency and fat repellency. So when we talk about PFOS related substances, we talk about all chemicals which have this part of PFOS, and then you can substitute here. And in total, there is a OECD list of 165 PFOS-related substances, yeah, which have different substitutes here at this position. So here, that's one example for an amide, and this chemical is volatile and can be transported by air. But PFOS and also PFOA, they are hydrophilic. They have an acid group here. And so this is the first POP which is really water soluble. So for PFOS, you can dilute 519 milligram per liter. And what I said for surface repellents, you just make a covalent bond from these amides, yeah, here to the textile or to the carpet surface, and then you get a surface on the carpet, on the textile, on the paper, which at the same time repel water and repel fat. So you are using it for synthetic carpets, or when you buy a couch, and you will find the description that this is water repellent, fat repellent, stain repellent. Yeah, then often this fluorinated surface treatment is used. Because of these many uses and they are good performance, also as industrial chemical, PFOS and related compounds were listed in Annex B. This means including acceptable purposes. Yeah, so only DDT was before listed in this Annex B. So this means there is no alternative available in some countries, and therefore for these acceptable purposes, countries can ask for continuous exemption. And in the beginning, about 8 of these Annex B exemptions were listed, including photo imaging, metal plating, firefighting foam, aviation hydraulic fluids, and also insect bites for specific leaf cutting ants. Over the last 10 years, then a range of these uses could be substituted with alternatives. So therefore, today, we have only one listed acceptable purpose for PFOS. This is this insect bite for the leaf cutting ants. But they are only, the leaf cutting ants are only in South America. Additionally, PFOS was listed with specific exemptions. Specific exemptions are uses where alternatives are available, but often developing countries does not have access to these alternatives. So therefore, these specific exemptions are also granted for 5 years. And after these 5 years, it is assessed again. And if countries further request exemptions, this can be prolonged for more 5 years. So what happened here is that also a wide range of exemptions were listed in the beginning in 2009, including also the coating of carpets and papers, textiles, leather, chemical-driven oil production, photomasks. But over the last 10 years, also those exemptions have been removed. So today, specific exemptions which are allowed for PFOS are the metal plating, and here the hard metal plating only in closed loop, and the firefighting foams, yeah, especially for liquid fuel vapor suppression of liquid fuel fires, so-called Class B fires. Always good to understand the total historic production and use, to understand where the most relevant for inventory is. So here you see PFOS has already been produced before the 1970s, but in the 1970s, the productions have increased considerably, with highest use here in the 1980s, 1990s. And then in 2001, there was a strong drop because the 3M company, US company, they stopped production here in 2000 and the sales 2002 because it was discovered that basically all blood in America was contaminated with PFOS. So it said it's a voluntary phase out, but of course the company understood the big risk for their overall business, and actually now these companies are also sued in the US over the years and have to pay much compensation. So in total, nearly 100,000 tons have been produced. 26,000 tons were in production waste, which is mainly disposed in landfills around the production sites. And after the US have stopped PFOS, also Germany stopped PFOS, then the Chinese have started PFOS production, but at much lower rates. So here the peak production was at 4,500 tons per year, and the production in China in the last 10 years was around 200 tons of PFOS per year. And there is an ongoing CHEF project in China to phase out the PFOS production and use completely. It is interesting to check for the inventory also the major use. And here a very good list is the yearly use here in Europe in 2000. You know, 2000 was the time of the major use. So by this, you can have a good feeling what are the uses, the major uses in history. And what you see here, about 500 tons have been used here in the European Union in 2000, and more than 90% went to this fiber coating, yeah, and to the paper and on polymer surface, yeah. A smaller amount went to chromium plating here, 10 tons, and the others like this photolithography, aviation, that was all lower than 1 ton. And also firefighting foam, which you will find in many publications, actually had a relatively small overall amount, but because the firefighting foam is directly distributed to the environment, today very much of the contamination comes from this firefighting foam use. But it's clear also this former use here in surface treatment of textiles, carpet, and so on is very important in respect to the inventory of PFOS which have went into landfills in the last 40 years. So PFOS is only a small part of the story of all perfluorinated alkylated substances. So for PFOS, you have here 8 carbons and a sulfate group, but you can also have a shorter carbon group. So by this, you get shorter sulfonates. You can make another terminal group here, a carboxy group, and make different chain lengths. You can make a hydroxy group. And as you have seen with PFOS, you can add here different substitutes. And by this, making hundreds and thousands of different compounds. So what has been, PFOS has been listed in 2009, and 10 years later then, the sister of PFOS, PFOA, which is also carbon 8, but has a terminal carboxy group. Yeah, so this has also been listed in the Stockholm Convention in 2019, and currently guidance materials and inventories are starting. And then this year, the long chain acids were proposed by Canada to the POP Reviewing Committee to be listed in the Stockholm Convention. And next year, the perfluorohexane sulfonate, this means the shorter brother of PFOS, will be listed in the Stockholm Convention. So what you understand by this is that these PFAS groups become more and more important in the Stockholm Convention, and I hope that I can show you in this presentation why they are so important. Also, the strategic approach to international chemical management, SCRC-KUWAIT, has listed all PFAS as an issue of concern. So coming to PFOA, yes, has been listed in the Stockholm Convention in 2019. It was not listed in Annex B, it was listed in Annex A, but also with a wide range of exemptions, including firefighting foam, different photolithography, photographic coatings for textiles, which need to be oil and water repellent, including here surgery textiles, medical devices, manufacturing of fluoropolymers, other manufacturing of plastic products. And here these fluoropolymers, for example, you have in daily life, like in this Teflon pan, or here for the muffin cups, that they can be easily moved out when you bake cakes. They are toxic and they bioaccumulate. So it was quite strange for me when I learned 10 years ago, 15 years ago, that a water-soluble compound like PFOS and PFOA can bioaccumulate. So these chemicals have also several years here. For PFOS, 3.4 years half-life time in humans. For the hexasulfonate, even 5 years. And by this, they accumulate. And the reason is that they can stick not to fatty tissues like PCBs, but that they are getting attached to the proteins and to the enzymes. So they have another mechanism of accumulation in the human body. And by this binding to proteins, they accumulate then in the liver, in the kidney, in brain, and in spleens. In animal studies, PFOS and PFOA cause cancer, neonatal mortality, physical development delays, and endocrine disruption. In humans, higher maternal levels of PFOS and PFOA were associated with delayed pregnancy. And also higher PFOS and PFOA level reduce human semen quality, sperm quality, testicular volume. So this is of high concern, because when you look to industrial country studies in Europe, we see that over the last 50 years, the sperm quality has halved. This means the man sperms have only about 50% amount of healthy sperms compared to 50 years ago. And that's one study here from 2009 from Jensen, from 120 young Danish men. And you see that the background levels for the population with higher PFOS and PFOA level have statistically significant lower sperm quality compared to the background level in the population. So and these are not people which are specifically exposed by occupation. So they are just exposed by the daily intake from drinking water, from food, and so on. So this is only one of the impact factor for sperms. There are other chemicals and there are other impacts which reduce the sperm quality, but you see here the relevance for PFOS and PFOA. And also when you look to the work of the European Food Safety Authority, this is the authority in Europe which defines the tolerable weekly intake for a chemical. You see over the last 10 years that this tolerable daily intake and weekly intake has reduced by a factor of about 100 for PFOS and 1,500 for PFOA. So over the last 15 years, many of new effects has been discovered at quite low rate. And the worrying thing is that the tolerable weekly today for Europe shows that a considerable share of the population is above this tolerable weekly intake. And most probably this is the case also for other populations in other areas. So always when a population is about a tolerable weekly intake, then urgent action is needed to reduce and eliminate releases and the use and reduce exposure to humans. So like I showed yesterday, here the life cycle of a POP, we have a bit different life cycle here for these PFOS and PFOA. Again, yes, the production and the release from production, the use of these PFOS, PFOA in products, in the production of carpets and papers and related releases. Then it goes into consumer products. From these consumer products, it goes into the environment and finally into reservoirs like landfills. And from these products, you directly have a strong exposure to humans and to the population here, especially in the indoor environment. And very important, like I said, for the first time, this is a POP which can contaminate here our water supply. And by this, directly we can get POP exposure for PFOS and PFOA in the drinking water. Furthermore, because of water solubility, PFOS and PFOA and other PFAS can be transferred into plants. So this means that not only these POP accumulate here in animal and in fish and we get exposure, but it is the first POP where we can get a relevant exposure from plants and from contamination of the soils, but also from irrigation water. Yeah, and here I see a big risk for the whole Middle East in respect to your water shortage and in respect to the recycling of water and using grey water also here in agriculture, and a big research need. So this is a study from Japan about the uptake of PFAS by rice. So you see the details how PFOS and PFOA is taken up by the rice plant and in what part of the rice it is going. So you see that there is big research ongoing for this. And I think it would be really important for the whole Middle East. I mean, there is completely no research in the Middle East on that matter. I mean, you can learn from the others, I mean, like this case study, but then the next step is also you need to check in your country what is here the flow and what is the impact of your food. And the first thing what need to be done is really a structured inventory of the use and the contaminated sites. So therefore, it is very important, I think, here for the Stockholm Convention, we have developed inventory guidance, and like all inventory guidances for industrial POPs, there is a first introduction chapter to the chemical and how it is included in the Stockholm Convention, how it is listed, then background information on production and use of PFOS, then a chapter on general inventory steps, and after that, then details on the different areas like industrial uses of the chemical, professional uses like this firefighting foam use or the use in pesticides, then the PFAS in the consumer market, finally in the waste phase, and in contaminated sites. Today there is not a PFOA inventory guidance yet, but I know that over the last year the BRS Secretariat, Basel Rotterdam Stockholm Secretariat, is working on it, and I expect that in the next few months there will also be a guidance for PFOA inventory. Also, as for other industrial POPs, we have a 5-step approach for the inventory development, planning the inventory, like establishing a national inventory team, key stakeholders, define the scope, develop the work plan, choosing the data collection methodology, collecting and compiling the data from the different sectors, then managing and evaluating the data, and finally compiling an inventory report, which then would go into the national implementation plan. So national inventory team is always multi-stakeholders, the necessary ministries, but also customs, very important, the private sector who is using these chemicals, like, for example, firefighters or importers of firefighting foam, NGOs, research community, where I also said, yes, this material flow analysis would be quite useful. Then define the objective and develop of a work plan. in respect to choosing the methodology for data collection, all the inventory guidances are developed with a so-called tiered approach, that all countries, depending on their capacity, can at least develop a simple desk study. Yeah, so also here for Palestine, where you said at the moment, I mean, we do not have the resources, we do not have the money, we do not have the analysis. Still, the guidances are developed in a way that you can make the first step. Yeah, so it guides you to do how to do an easy desk study, to compile all the information, and maybe go to a second stage, a tier 2 inventory, where you can look into detailed statistics, where you can contact the stakeholders, but all without any measurements. Yeah, so most of the countries in the world which have developed inventories of PFAS have done this kind of tier 2 inventory. And already there, let's say the information is highly relevant and useful to take actions from the governmental side, like to tell to companies to stop the use, yeah, or let's say to control the use of these chemicals. And if there is capacity, then you can go to a tier 3 inventory, which often includes sampling and analysis, yeah, to understand, okay, what groundwater is really contaminated, and which of the groundwater is not contaminated. Then the step 3 is collecting the information, going to the industrial sector, looking to the consumer market, looking to the different professional uses, going to the waste management and understanding, for example, what happens with our synthetic carpets. Are they all going to landfills, or are they partly recycled? And very important, contaminated sites, I will come later. So when looking to the different major uses and stocks for the inventory, I see here the major areas for the inventory task. The first and one of the most important is firefighting foams, yeah, here for PFOS. Then to check if there is any metal plating in the country. Then if PFOS is used as insect bites, the synthetic carpet use and especially the stock of synthetic carpets, end of life management of synthetic carpets, understand textiles and the treated paper and packaging. And the paper which are treated are, for example, the paper from fast food packaging. Yeah, here McDonald's, Kentucky Fried Chicken, name these companies. So here often the food packaging is treated with fluorinated compounds, that the fat is not going from your Big Mac into your hand. But in Europe, for example, Denmark has prohibited all these uses of food packaging. Then chemically driven oil production, very relevant for the region. Then, but you know, for lower uses here, PFOA are still exempted, photo imaging, photoresist, photo masks, certain medical devices, important for some countries here, the manufacturing of fluorinated polymers and some other fluorinated polymers and the manufacturing, for example, of electrical wires. So these are, let's say, the major area to look in PFOS and PFOA use. And last not least, the textiles. But I have shown you these are specific textiles like the outdoor use textiles, which are water repellent, or the textiles here for surgeries, which need to be blood repellent. And like for PFOS, also for PFOA, it is still used in firefighting foams. So for the data collection, you would start here for the desk study with publications, starting with the inventory guidance. There is another interesting guidance for you from Stockholm Convention. This is a guidance to screen POPs in products. So this guidance I have developed and updated over the last 10 years. I think very interesting for both for policymakers, but also for university. Then technical reports, information collection from different organizations. And today, of course, most of the information is available by internet searches. Then there are different outreach mechanisms. Here, Shireen will tell you more details about the questionnaires which have been developed from Stockholm Convention and which are included in the inventory guidance as an annex. Also, Shireen will tell you more in Arabic about the outreach mechanism. So I will not go into detail for this. Site inspection can be quite important, especially to understand what kind of firefighting foams are used. And here we can come back to the question in the beginning of the day for the environmental police. Yeah, so they could be quite useful here, getting access, even the use of firefighters, but also military is using much of this firefighting use. And often here, if a student would do this kind of inventory development, he would not get access to these data. So it need to be a combination. Then what I find useful, and this you can download, this is a material substance flow analysis of PFOS for Switzerland. So they have looked into what kind of products and use are most important in their country and have quantified it. They have looked into the waste management, where do then finally the products and the uses end up, and how these kind of compounds go into the environment, into water, into the atmosphere, and into the soil. So here just a bit to the result of Switzerland. They found most of their PFOS was in firefighting foam use and in storage. A part was still in service life, like in the carpets or like in textiles. Much of the uses had already ended up into landfills for Switzerland. And Switzerland uses for today 100% of their municipal waste, which is not recycled, in incineration. Yeah, but also by studies they found a big part is going into wastewater treatment plants, and from wastewater treatment plants directly into the hydrosphere, being surface water or being groundwater. Coming to the last part, to contaminated sites. So the whole life cycle of PFOS and PFOA results in contaminated sites, contaminated soils, and contaminated groundwater. So the major sites potentially contaminated with PFOS and PFOA and related substances are starting from the production of PFOS and PFOA. You don't have in Palestine. Also fluoropolymer productions and related landfills you do not have in Palestine, but for sure you have sites of the firefighting practice area and firefighting use area. Yeah, already the firefighting practice area is contaminated. This includes airports, refinery, oil storage sites, military areas, other firefighting practice areas. Sites where PFOS and PFOA have been used in industries, like in the plating industries, production of synthetic carpets, certain production of textiles, impregnation of leather, certain paper industry, sites where PFOS, PFOA containing product waste has been disposed using industries, and generally landfills where these products finally end up. Yeah, including the synthetic carpets, but also these papers from food contact materials, for example, from fast food. So here just a few practical examples. What you see here is a German site where firefighting foam has been used in a case of a fire. Yeah, then this goes finally into the ground, and over time it contaminates the groundwater. This is the German city of Dusseldorf, which over more than 10 years have done a complete assessment of their groundwater and have found that they have about 10 PFOS, PFOA larger contaminated sites. The biggest contaminated site is here, the airport, but some other firefighting foam use, including the one I showed the picture before, but also contaminated sites here from chromium plating, metal plating areas. And over time, these contamination are migrating, and unfortunately they are migrating to the water wells. Yeah, so this means if you have a groundwater contamination in Palestine, which is a few hundred meters from a water well, and you are pumping drinking water, or you are pumping water for agriculture, over time, by pumping and sucking, these PFOS and PFOA are migrating to the water well. And this is for the neighboring city of Düsseldorf, a major water well, which has been contaminated here from the airport and needed to be stopped. What you see here is the only and best inventory of PFOS, PFOA contaminated site of a country. That's from the United States. And here the US EPA has analyzed 36,000 water samples of drinking water and groundwater, and found that 6 million US citizens exceed the US EPA's Life Guide Health Advisory of 70 nanogram per liter, which was developed around 2015. So 6 million Americans are above 70 nanogram per liter. And over the last 6 years, like I said, for Europe, these levels were reduced by a factor of 10 to 100. So considering US Center of Disease Control, but European Food Safety Agency, today the 70 nanogram per liter is at least 10 times or even 100 times too high. So when you would set about 1 nanogram per liter as an acceptable level for drinking water, then 200 million US citizens would be above this limit. Yeah. So you see how relevant this is for exposure of the population, and that a global systematic inventory and assessment of PFOS and PFOA contaminated site is needed. As a last example, this is the release from landfills. So basically all landfills containing consumer waste today, the leaching water, contain PFOS and PFOA. So they are leaching out of landfills over the years and over decades and probably longer. So quite relevant for our drinking water resources in future. And PFOS and PFOA have been substituted over the last 20 years. Like I said, probably around this year or next year, the last PFOS production will stop. And the alternative which are used are often the shorter chain PFOS and PFOA. So today, when you look into the use of PFOS, PFOA, there are more than 4,700 PFAS on the market. US EPA has made a compilation of more than 6,000 CAS numbers. And when you, for example, look to firefighting foam, often as alternative, other PFAS are used in these firefighting foams, which are also contaminating the groundwater. The good news is that today also a complete PFAS-free firefighting foam alternatives are used. Yeah, and here also in your country, in Palestine, you can, when you do your inventory about your firefighting foam, you can check what is today used, are other alternative foam used, and maybe can we directly switch to fluorine-free foams. So by this, let's say you can skip some of the steps and directly by developing the inventory also look for implementation for substitution of PFOS and PFOA, and additionally substitution of all PFAS, because this is at the moment now the recommendation of the European Commission in its chemical strategy for sustainable towards a toxic-free environment. The European Commission is suggesting not only to address PFOS and PFOA, but to address PFAS as a group with the following action: to phase out and use of PFAS in the European Union only unless their use is essential. And the same is a recommendation by the science groups here, that we substitute not only PFOS, PFOA, but that we substitute PFAS as a group where a substitution is possible, and where a substitution is not possible, to control these PFAS in their life cycle. Thank you for your attention.
Thank you, Roland, for your wonderful presentation. You have shared a lot of information. So now I am giving the floor for 5 minutes for the discussion. So I can see one hand, Gazan Barghouti. Okay, please go ahead. You can, yeah.
Thank you. Thank you, Roland, for this comprehensive presentation. But I have a couple of points, but I have to summarize them quickly. The first one is about the PFOS. When you started, and you mentioned that these kind of compounds are kind of volatile compounds, even though they are characterized by amidic bond and relatively high molecular weights. So I think, I don't know where is the volatility came from. The second point is about the level that being detected in water samples or others. What kind of instrument that being used, and the limit of detection for that?
Yeah. Wait a moment, maybe then we start first. So the PFOS itself is water soluble because normally you have it in ionic form, also PFOA. Only the amides, and you know, because they are so repellent. I mean, also when you look when you look to PCBs, for example, so they have also a boiling point of 250, 270, 280, 300 degree, but still they are partly volatile, and then they can do this kind of migration. Yeah, so it is not like for water or some solvent, yeah, that they are directly completely evaporate, but it is rather that they slowly evaporate and can migrate, the amides. Yeah. Mm-hmm. So the polymers itself, of course, they are sticking, so that you have seen they are covalently bond. Mm-hmm. Yeah. So these covalently bond compounds, of course, neither volatilize nor they go to the water. But over time, these covalent bonds can break over the years, over the decades, and even probably over the centuries. Yeah. So there is a test, for example, in a bioreactor for a landfill, and then you see that over time, PFOS and PFOA or other PFAS increase when you do a bioreactor, for example, with this carpet, where the biggest part of the PFAS are covalently bond. Yeah, and then also the most go into the water phase. I mean, as soon as you have them ionic, they are water soluble. So let's say PFOS itself does not go into the air. So only some of the precursors like the amides. Coming to your question about the analysis, you can analyze those both HPLC and GC. Normally you use HPLC-MS, yeah, HPLC-MS. So this is the preferred analytical instrument which is used for PFAS. There is one complication. Often in these analytical instruments you have Teflon parts, and if you have in a HPLC MS Teflon parts, you cannot analyze PFOS and PFOA and other PFAS because the Teflon parts contain PFAS. So you get a blank value from these compounds. And also you see often in the laboratory you have Teflon parts. In many of when you shaking you have Teflon cocks and other materials are often Teflon coated. So when you want to establish a PFAS analysis, the first what you need to do in a laboratory is phase out the Teflon and other fluoropolymers. Yeah, so that's a one challenging issue. About detection limit. Today, it is no problem to measure a nanogram or even go to picogram with these instruments. But then we also can come to the laboratory blanks. So a good friend of mine, he's head of the largest dioxin laboratory in Japan and POP laboratory. So when I told him that now in Europe they want to go down to detection limits in meat or food to the nanogram range, 1 nanogram, 10 nanogram, he said that he thinks that this is not possible just because of the background in the laboratory. Yeah. So here we come to the topic. Yes, by instrumental analysis, you can even detect below 1 nanogram per kilogram. Yeah. But in the laboratory itself, the blanks are normally too low, and you really need to have a very specific laboratories that they can go down to the low nanogram level per kilogram of meat or milk or something. You can analyze with GCMS. There are also publications, but like I said, normally the HPLC is used.
If time permits, I have 2 more points. I don't know.
Yes, please quickly.
Okay. A very short question. At the end, you said they are going to shorter, let's say, PFOS or PFAS.
Yeah.
What I expect is this kind of lower molecular weights. It's more water soluble, which might, I mean, go faster to contaminate groundwater. This is one point. The second point, is there any kind of, let's say, it might be a research question about the treatment, let's say, the treatment of PFOS or PFAS or the removal, let's say.
Yes, of course, yes. So, okay, first, when we come to the PFAS, why they move to the shorter PFAS. The shorter PFAS is not only much more water soluble, they are also more water soluble in the body, and they do less accumulate. This means when you go to the C4 acid, the half-life time might be only a few days. And also, let's say the toxicity is lower, yeah, of the shorter chain. But there is much unknown about toxicity, so they are under-evaluated in respect to toxicity assessment. But you are absolutely right, they are more water soluble and much more quicker in the groundwater, and they accumulate much better in the plants. So therefore, in Europe, we have made a new criteria for substances of very high concern, because if you have only the short chain PFAS, they would not meet our normal criteria for substances of very high concern. but now we have a very persistent and very mobile as a criteria for this short chain PFAS, because it's then later, and this comes to your second question, very, very difficult to remove those. PFOS and PFOA can be removed by activated carbon, for example, in drinking water. But when we come to the shorter chain PFAS, they are much more difficult to remove from the drinking water. Yeah, so this is one reason why authorities and researchers are let's say, alarmed about this shorter PFAS. We cannot control them in the life cycle, and they really go into plants, in the plant food, and into our drinking water. And it's so difficult and costly to remove them, you know, reverse osmosis and so on, too expensive.
Mm-hmm. Thank you so much. Thank you.
Yeah, very welcome.
Thank you, Roland. I think there are 2 questions in the chat box. Can you just see it?
Okay, yes, I'm in the chat box. Wait a moment. Here the first time, a practical question. Okay. Do Palestinian Water Environment Related Agency the lab equipment for screening or analysis of PFAS? Like I said, probably.
Hold on, Roland. Before that, there was one general question. Was there?
Okay, good.
Yeah.
General question: what quid loops in water bodies, drinking water, reclaimed water for PFAS, known as the forever chemicals in the EU? General question. What?
I didn't get that point. That's why I asked you to.
Quid loops. What are quid loops in water bodies? Can you, maybe the person who asked the question, Rashid Al-Saif, maybe you can, if you can open your microphone.
Yeah, thank you very much. Excuse my bad English. I could ask that in German, but nevertheless, do we have in Europe or USA guidelines for the PFOs in the drinking water and in reclaimed water?
Yes, yes.
Thank you very much.
Yes, so there are in the whole world are guidelines for, or in many countries are guidelines for drinking water. So you can look to the US and to Europe. In the US, it is rather the different states which make the limit in the drinking water. This means you do not have an overall limit. So still this US EPA 70 nanogram is the health advisory, but which now everybody knows is not useful today. So there is, for example, one, I think Virginia, or Vermont, which have 20 nanogram in drinking water. And I think when you recalculate, even the drinking water limits will become lower. Like I said, when you take the tolerable weekly intake from the European Food Safety Agency, we will need probably to come to a drinking water limit for these PFASs below 10 nanogram per liter. What Europe has done is they made now a limit for all PFAS, which is at the moment also relatively high, because you know you have a drinking water commission and they have to decide on a limit. And at the same time, you have another commission which is developing, let's say, health advisory limits. And often the one make a limit, and then the other group, which is working in parallel, make then a limit for tolerable weekly intake. So here, like I said, I would see that we will come to drinking water limits below 10 nanogram per liter. At the moment, the lowest limit is at 20 nanogram per liter. I will give you a link to our paper. We have done a review of all the drinking water values in China, where we also said that about 100 million Chinese is above the health advisory of the US EPA, and no, above the 20 nanogram per liter of Vermont. And there we have mentioned more about the limits. Yeah, so I will send the link to you in the chat afterwards. And then the last one, I'm standing in front, testing laboratory center of Birside University that has some of equipment, but requires upgrades. So like I said, yes, you will need this, let's say, HPLC and SMS liquid chromatography. But here I also would recommend you make a cooperation with a research group. Yeah, and these research groups, they have good capacity. And I think that this is the best way forward to test your drinking water and to test your groundwater. Yeah, in the most short time, this might result in measurements of your drinking and groundwater and your irrigation water.
Okay, thank you.
Okay, thank you, Roland. I think the rest of the question I am requesting you to put in the chat